All right, at the top of your sheet here, we're dealing with empirical and molecular formulas. Empirical versus molecular. If you look here, what can we learn about the compound from its formula? Well, the empirical formula is going to show the smallest whole number ratio. You might want to highlight this. The smallest whole number ratio possible for that particular molecular formula. We use the empirical formula in calculations a lot to determine molecular formulas. The molecular formula is different because it's the actual number of atoms in the formula. We're going to do some examples here in just a minute too to show you how these two interact with one another and what you would need to do in order to find the empirical formula from the molecular formula. So looking at this chart here, empirical and molecular formulas. Over here they give us molecular formulas, okay, like H2O2, that is hydrogen peroxide. And if you look there, there's two H's, two O's. What common factor do they have between them? A2. So that's not the lowest ratio possible, but the molecular formula, it always has two H's, two O's if it's hydrogen peroxide. If we wanted to find its empirical formula, though, we would use its common factor and we would divide the subscripts by that common factor. So the empirical formula for hydrogen peroxide ends up being HO, 1 to 1. You would divide it by the 2 in order to get that. So let's look at the next example. Dinitrogen hexoxide. This one right here. What is the common factor between both elements? Another 2. We divide them both by 2, we get NO3. That would be the empirical formula. Now, interestingly enough, number 3, does it have a common factor? No, it's already in its reduced form. So, when it's already in its reduced form and you can't reduce it anymore, the empirical formula is the same as the molecular formula. So in that case, you would just rewrite it because the empirical formula and the molecular formula would be the same. Does anybody recognize number 4? It is glucose from biology. What's the common factor between them? A6. So if we reduce or we divide them all by 6, that was going to give us CH2O, right? And number 5, what's the common factor there? 5, so this one's going to be CH2. You kind of get the idea now. Let's just go over 6. That one's going to be PO4. Divide them both by 2 here. And then last but not least, the common factor in 7 is a 4, so this is going to be NH4. Okay, so I'd like you to move on to the next one and try some on your own real quick. Answer that question there. So here you're looking for the compounds that do not have the empirical formula CH2. So go ahead and figure out their empirical formulas and then circle the ones that are not going to have CH2 as its empirical formula. All right, let's look here. The next one, C3H5 is already reduced to its lowest ratio, and it is not one that is CH2. The next one, the common factor in 3 is a 3, so yes, it reduces down to CH2. This one, of course, is the common factor between 12 and 22 for number 4 is going to be a 2, so it goes to C6H11. And last but not least, the C12H24 will also reduce to CH2 because the common factor would be 12 there. So the ones we would circle would be number 2 because that one, the empirical formula, did not come out to being CH2. And also number 4 because that one did not reduce down to CH2. So you're going to have a problem like this where you have to make sure they reduce, okay, and be able to check and see that they match, okay? Now for calculating, we have one little calculation that we must do. You can calculate the molecular formula of a compound if the molar mass of the molecular formula is given along with the empirical formula. Okay? It's a simple equation here, mass of the molecular formula divided by the mass of the empirical formula. That's going to give you N. And we call N a multiplying factor. This is a multiplying factor. We're going to use that multiplying factor to figure out the molecular formula. So I know it's cut off a little bit here. It's the molecular formula equals the empirical formula times the multiplying factor N. Very simple, straightforward math problem here. It's a simple division and then a quick multiplication. So let's look at the first example. Determine the molecular formula for a compound OF2 oxygen difluoride that has a molar mass of 107.99 grams per mole. So the first thing I need to do is find the empirical formula's mass. That's what I'm going to do first. So O, 1 times 16 gives me 16. The F's, what's the molar mass of F? 19, good, there's 2 of them, so I'm going to multiply that by 2 and we get 38 for that. So this ends up being what? 54 grams per mole. That is the empirical formula's mass. Empirical formula's mass. Now, all we have to do is follow the equation. We take our molecular formula's mass here, 107.99. We divide it by the empirical formula's mass, which was 54. And that's going to give us our N, or our multiplying factor. What does N end up being? N equals 2. Okay, very easy. It should be a whole number, by the way. Should be very close. It could be like 1.99 or 2.01, but it should be very close to a whole number. Then all we have to do is take our OF2 and multiply all the subscripts by 2. So this ends up being O2F4, and that would be our molecular formula. So go ahead and try the next one real quick and see if you can work it out. Okay, determining the molecular formula for the compound C2H3O2. Okay, so here we go. Finding the empirical formula's mass. So we have carbon 2 times 12.01. That will give us 24.02. Hydrogen 3 times 1.01. That's going to give us 3.03. And oxygen is going to be 2 times 16. That should give us 32. When you add all this up, ends up being 59.05. Very good. Trying to do the mental math wasn't working for me. There you go. 29.05 is correct. Now if we take our molecular formula mass, 118.1, divide it by our 59.05, what's the multiplying factor? It is also a 2, so then we take our empirical formula C2H3O2 and we multiply it by 2, resulting in C4H6O4 would be your final answer there. So that would be the molecular formula calculated using the molar masses. So there will be one problem like this also on your quest. Make sure that you can be able to calculate these. And they show up on the SOL as well.